So the last set of equations that we will see are the product to sum formulas and the sum to product formulas. So let us start with product to sum. So basically what it will do is we'll take a product of trigonometric functions and make it into a sum of trigonometric functions. So assume we have a product sine alpha times cosine beta, then this formula equals 1/2 of sine alpha plus beta plus sine alpha minus beta. If we have cosine alpha times sine beta, that is 1/2 of sine alpha plus beta minus sine alpha minus beta. We can also have two cosines, so cosine alpha, cosine beta. If we multiply this, that's equal to 1/2 cosine alpha plus beta plus cosine alpha minus beta. And then the last one, if we have a product of sine alpha with sine beta, then we get 1/2 times cosine alpha minus beta minus cosine of alpha plus beta. The proof of these formulas is very straightforward. So you just take your sum formulas, which we saw before. You plug them in on the right hand side and you work the right hand side out to obtain the left hand side. Let's take a look at the following example where we can use the formula. So let's say we want to express sine of 3x times the sine of 5x, and we want to express them as a sum of trigonometric functions. So how do we do this? We start with sine 3x times sine 5x. And then we just apply the formula. So we know this is 1/2 of the cosine of the difference, so 3x minus 5x, minus the cosine of the sum, so 3x plus 5x, meaning it's 1/2 cosine minus 2x minus cosine 8x. And now we know cosine of a minus an angle is just the same as the cosine of the angle, so it's 1/2 cosine 2x minus 1/2 cosine of 8x. The last set of formulas was sum to product, as we already said. So sum to product formulas. You have a sum, so sine alpha plus sine beta, and you want to express those as a product of trigonometric functions. So sine alpha plus sine beta equals 2 times sine alpha plus beta over 2 times the cosine of alpha minus beta over 2. We also have sine alpha minus sine beta. This is 2 times cosine alpha plus beta over 2 sine alpha min beta over 2. If we have a sum of cosine, so cosine alpha plus cosine beta, then it is 2 times cosine alpha plus beta times the cosine of alpha minus beta over 2. And the difference, cosine alpha minus cosine beta, the thing we didn't have yet, it's sine times sine, so it will be minus. So here you have to pay attention for the minus sign. It's minus 2 times the sine of alpha plus beta over 2 times the sine of alpha minus beta over 2. To prove this, we will just show one. So as proof, what we can do is set theta equal to alpha plus beta divided by 2, and phi is alpha minus beta divided by 2. And we will look at sine times cosine. So we take the first one, so this one. So we have 2 times sine alpha plus beta over 2, so that's sine of theta, times the cosine of phi. Using then the product to sum formulas, this is sine of theta plus phi plus sine of theta minus phi. And then if we look at theta and phi, so theta plus phi is alpha plus beta over 2 plus alpha minus beta over 2. So it's 2 alpha over 2 or alpha. Similarly, theta minus phi will be equal to beta. And so this formula is just sine of alpha plus sine of beta, which is the left-hand side of expression 1. All the other formulas are similar, so you do a similar reasoning. You start from the right-hand side and you obtain the left-hand side immediately from the product to sum formulas. Also for this one, a small example. So, example, prove that sine of 3x minus sine of x divided by cosine 3x plus cosine of x, that this equals tangent of x. So try this yourself. So pause the video, try to solve this exercise and then come back for the result. So the solution is quite simple. You just take the left hand side and you can immediately apply the formulas. So sine of 3x minus sine x. So this is a subtraction of two sines divided by cosine of 3x plus cosine x, which is a sum of two cosines. So we apply the formulas. The upper one is equal to sine x. The lower one is equal to cosine x. And so the total is tangent of x. So far, in all the examples that we saw, we knew which formulas to use. However, in practice, and this holds also true for your exam, you will just get a formula or an identity and you will have to prove it with any means necessary. So you don't know which formulas to use and you will have to try until you find the correct ones. So we will see some of those now. So prove that 1. Prove that cosine of 18 degrees minus the sine of 18 degrees over cosine of 18 degrees plus sine of 18 degrees equals the tangent of 27 degrees. Prove that if you have three angles, alpha, beta and gamma, and basically they form a triangle, so the sum is pi, and you also know that cosine of alpha equals cosine beta times cosine gamma, then, so this is the part you have to prove, then the tangent of alpha equals tangent of beta plus the tangent of gamma. And then the third one, prove that the cosecant of theta minus 2 times the cotangent of 2 theta times the cosine of theta equals 2 times sine of theta. So start with the first one. So we start from the left hand side. So the left hand side was cosine of 18 degrees minus the sine of 18 degrees divided by the cosine of 18 degrees plus the sine of 18 degrees. One way to solve this is by dividing numerator and denominator by cosine 18 degrees. So basically we are not changing anything because these two cosine 18 degrees can cancel each other out, but it will change the formula. So what we then obtain is 1 minus the tangent of 18 degrees over 1 plus tangent 18 degrees. And now we start to see a formula. So you had tangent alpha plus beta was tangent alpha plus tangent beta divided by 1 minus tangent alpha tangent beta. So here what we need is for this one to become a tangent and The good thing is we also have a 1 here, so we can put in the same tangent. Which tangent equals 1? Well, the tangent of 45 degrees. So this is tangent 45 degrees minus tangent 18 degrees divided by 1 plus tangent 45 degrees times tangent 18 degrees. So we now have a formula tangent alpha minus tangent beta over 1 plus tangent alpha times tangent beta. So this is the tangent of 45 degrees minus 18 degrees, or what we needed, the tangent of 27 degrees. For the second one, we start with what we know. So we know that alpha plus beta plus gamma is pi. So you can rewrite alpha as pi minus beta minus gamma. Also, we know that cosine alpha is cosine beta times cosine gamma. So cosine beta cosine gamma equals cosine alpha. And then we will replace alpha with the formula that we just derived. So cosine alpha is also the cosine of pi minus beta minus gamma. So always first use the things which are given to go to the end of the proof. So you start with what is known. In this case, the three angles together are pi, and your cosine alpha is cosine beta times cosine gamma, and work from there. So cosine of pi minus some angle is minus the cosine of the angle. So this is minus cosine minus beta minus gamma. Then you also know that a cosine of a negative angle is the same as the cosine of the angle. So this is minus cosine beta plus gamma. And then we just apply the formula. So cosine beta plus gamma, this is cosine beta times cosine of gamma minus sine of beta times sine of gamma. Or when we take in the minus sign, this is sine of beta sine of gamma minus cosine beta cosine gamma. What we now see is in the equation here that on the left hand side and the right hand side we have a multiplication of cosine beta and cosine gamma. So we bring those all to the same side. So when we rewrite, this gives me 2 times cosine beta times cosine gamma is equal to sine beta sine gamma, or if we divide out, 2 is equal to the tangent of beta times the tangent of gamma. So now we have used up everything that we know, and it's time to move on to what we have to prove. So we want to prove that tangent alpha is equal to some other formula. So we start off with tangent alpha. Tangent alpha is, as we already saw, the tangent of pi minus beta minus gamma. This tangent is the same as the tangent of minus beta minus gamma. And we also know that the tangent of a negative angle is the negative tangent of the angle. So here we can take out the minus, so to speak. So this is minus the tangent of beta plus gamma. Tangent of beta plus gamma, we use the formula. So this is minus tangent beta plus tangent gamma divided by 1 minus tangent beta times tangent gamma. And then we know from here that this is equal to 2. So we get on the bottom 1 minus 2 is minus 1. So this is just the tangent of beta plus the tangent of gamma, which is what we needed to prove. And then for the last one, we start again from the left hand side. So the left hand side was cosecant of theta. Cosecant is 1 divided by sine of theta. So it's always a good idea to write them out as a fraction. It might help. Minus 2 times the cotangent of 2 theta. We will write as cosine of 2 theta divided by the sine of 2 theta times cosine of theta. This is equal to 1 divided by sine of theta minus 2 times cosine 2 theta. So don't be too hasty in changing formulas. So here we will for now leave cosine 2 theta as it is, times cosine theta. But we will change the sine of 2 theta, which is 2 times sine theta cosine theta. Why? Because we can delete the factor 2 and we can delete the cosine. So it is 1 divided by sine theta minus cosine 2 theta divided by sine theta. So it's 1 minus cosine 2 theta divided by sine theta. And now we see that we have a formula 1 minus cosine 2 theta, which you would have missed if you had replaced cosine 2 theta by something else. So this is 2 times sine squared of theta divided by sine theta, or 2 times the sine of theta, which is equal to the right hand side, so which completes our proof.